This section, we're going to use parallel lines. What does it mean for lines to be parallel? Parallel lines what? Y'all tell me. They never what? They never intersect, okay? So in order for what I'm teaching you today about the angle relationships, in order for that to work, you must be using parallel lines. Okay, so what are parallel lines? Well, that's what we see here in this diagram, right? Line P and line Q, they have the little arrows on the lines, and that shows that they're parallel. Opposite to that is something called perpendicular lines. We're not really going to spend a whole lot of time today talking about perpendicular lines, but perpendicular lines cross to form 90-degree angles. So if I see lines that are perpendicular, spit it out. Okay, if I see lines that are perpendicular, I know that they can cross to form 90-degree angles. Okay, now this point down here is really important in your notes. I need you to highlight it. I need you to star it. A line that intersects two parallel lines is called a transversal. Transversals create several pairs of congruent angles. Okay, so that's what we see happening here, all right? So we had a transversal that cut through, just like we just did over there on the screen too. We have a transversal line T that has cut through my two parallel lines A and B. All right, look up here, okay? And when that happened, it created all of these angles. So because the lines are parallel, I have these angle relationships. All right, this is not in your notes, so you just need to pay attention. I have all of these types of angle relationships. All right, so let's talk first about corresponding angles. Corresponding angles are in the same location on two different intersecting points. So we see 75 degrees. All right, does everybody see that 75 degrees is in the top right section of that intersection? Does everybody see that? Which angle is in the same location on the other intersection? 6. So here's what my rule says. Corresponding angles, angles that are in the same location, have the exact same measurement. So I don't have to measure angle 6. I know, because it's in the same location as 75 degrees, that it is also 75 degrees. I want you to write in 75 degrees right there on your notes. Okay? It's actually down below. Okay? All right, and we're going to answer, so we're kind of answering another section. Okay? So I'm going to say one pair of corresponding angles. Well, I'm going to come back to that. Actually, I'm not going to use that pair. Can anybody give me another set of angles that are in the same location on both intersecting points? So we said 75 and 6. Can anybody give me another pair? Angeli?
2 and 7.
Okay, not 2 and 7, because 2 is in the top left. 7 is in the bottom right. Those are actually a different kind of relationship. Cade, what do you think?
3 and 7.
Okay, 3 and 7. Do you see that 3 is in the bottom right section? Does everybody see that? Does everybody see that 7 is in the bottom right section of the other intersection? Okay, so whatever angle 3 measures, angle 7 will be the exact same measurement. All right, so let's list that. All right, angle 3, you don't necessarily have to write this down in your notes, is congruent to angle 7. We're about to do more of this practice in just a minute. Okay? So now let's talk about vertical angles. Vertical angles are opposite each other and they are equal in measure. Okay? So they're diagonally opposite. So does everybody see angle 6 over here? Right? Which angle is opposite? Angle 4. And my rule says that they are equal in measure. So angle 4 would be 75 degrees. Okay? So one pair of vertical angles could be 4 and 6. All right, what does that equal sign mean with the squiggly on top of it? What does that mean? Congruent. It means congruent. All right? Does anybody live somewhere where you have a neighbor? Okay? Or have you ever been in an apartment complex? In apartments, they share those walls. You share walls with your neighbor, like in a hotel. If you've ever stayed in a hotel, you share a wall, right? Okay? So that's kind of like what adjacent angles are. They share a common side with another angle. Okay? And their measures add up to 180 degrees. So I want you to look at angle 6. All right? We're still going to focus on angle 6. Everybody looking up here? Okay? Angle 6 has a next door neighbor. Which angle? Angle 5. It also has a next door neighbor, angle 7, too. Angle 5 is its next door neighbor. Why? Because it shares that common side. Does everybody see that? So my rule says, if it shares a common side and it lies on a straight line, their measures will add up to 180 degrees. All right, this is something that you have learned. Okay, if you learn the 7th grade standards, this is in your 7th grade standards. So if their measures have to add to 180, and I know that angle 6 is 75, how do you think I can figure out the measure of angle 5? They need to add up to 180. You know one of them. What do you think? What do you think? Not everybody wants. You subtract them. 180 minus 75. What's 180 minus 75, guys? 105. So adjacent angles, my angles that are neighbors with each other, they need to add up to 180. So I'm just going to say angle 5 is congruent to angle 6. All right, and we're going to save numbers 4 and 5 for later on in the lesson. So we've learned, and should be a review, okay, because you did learn this in your 7th grade standards, whether you're a new student or you're a returning student. The corresponding vertical and adjacent angles usually are covered, okay? So actually this is not a part of your lesson because they expect you to know it, okay? But we needed to review. So now let's answer actually what they want us to solve, okay? So it says, use the figure to find the measures of angles 1 and 2. All right, so this is not a guess, okay? I need to figure out, this is kind of like a puzzle, right? Anybody like puzzles? I got to figure out how they're connected. Okay? So how does angle 1 relate to the given angle measure? Well, we just went over the types of angle relationships. So could it be corresponding? If it was adjacent, it would have to share a side with it. Well, they're on completely different intersecting points. So it can't be adjacent. Okay? Can't be vertical. But look at its location, guys. Look at the location of 110. Do you see that it's in the bottom left part of that intersection? Does everybody see that? Jose, are you paying attention? Okay. This is in the bottom left. Do you see how it's in the bottom left, Taylor? Okay. Look where angle 1 is. It's in the, what? It's in the bottom left. So what did we just say about corresponding angles? They are equal in measure. So angle 1 is 110 degrees. Okay, equals 110 degrees. Because, you got to tell me why. Because it corresponds, okay, you can abbreviate CORR, corresponds with the given angle. The given angle measurement. Okay? It's corresponding. What do I mean by corresponding? It's in the same location. So in one of my last classes, they kept saying, it's the same. Okay, well, yeah, it's the same, but why is it the same? It's because it's corresponding. It's in the same location. Now I want you to look at angles 1 and 2. Angles 1 and 2 here. What does that look like to you? Do they look like they're opposite from each other? No, so they're not vertical. Do they look like neighbors? Do they look like next door neighbors that share a common side? Yes. So they are adjacent. So my rule says that their measures must add up to 180 degrees. Well, that's really convenient because I know that angle 1 equals what? What does angle 1 equal? 110. Does anybody remember what I just said? If I know the measurement of one of the angles, how can I find the other one? Subtract it from what? 180. Okay. So angle 2 must be 70. But you have to tell me why. Angle 2 equals 70 degrees because it is adjacent. Here's how you spell adjacent. ADJACENT. To angle 1. Angle 2 is 70 degrees because it is adjacent to angle 1. All right? So you see, guys, we're not using a protractor. We're not actually physically measuring anything, but I know for sure that this is the measurement of these angles. Okay? All right. So I want you to answer these two questions. Tell me the measurement of angle 1 and angle 2, and make sure you can tell me why. The why is telling me what kind of angle pair it is. Is it adjacent? Is it corresponding? Or is it vertical? All right, I want you to go ahead and work on this and then pair up your answers with a buddy. Angle 1 is 63 degrees because it corresponds with the given angle measure. It corresponds. It's in the same exact location. Can anybody give me angle 2? Come on, I know somebody knows it. Jada.
117.
How did you figure out 117?
Subtracted by 180.
So she recognized that angles 1 and 2 are neighbors. Why are they neighbors? Because they share the common side. All right, they share that common wall, that common side. So that makes them adjacent. She can subtract from 180, and angle 2 is 117 degrees because it is adjacent to angle 1. All right, did that one make a little more sense?
No.
Did that make a little more sense? Okay, that they're right next to each other, so their measurements have to add up to 180. Taylor?
I didn't know how we're subtracting 180 with.
Mm-hmm.
But you said 63.
Yes. So angle 1 was 63 degrees. So angle 2, because they're adjacent, they have to add up to 180 degrees. So because of that, I can do 180 minus 63 to find the other one. Okay? All right, we're going to do more practice. Okay? So let's go ahead and move on to example 2. So example 2 is kind of like where we started, right? In that very first slide, I kind of put up all your different angle relationships. Noah, sit up. Okay? I put up all your different angle relationships, and I said as long as you can identify the relationship, you don't have to measure anything. You know what the angle measurement needs to be. Are you paying attention? All right, look up here. Okay, we're not chewing gum, right? We already spit out all our gum. Okay, spit it out, please. Okay. All right, so let's look at the given angle measurement, 75 degrees. 75 degrees. The angle opposite to that. So I would say out of all the different angle relationships, vertical angles are the easiest to pick out. Vertical angles are opposite each other and they are congruent in measure. So if the given angle measurement is 75 degrees, guess what angle 1 is going to be? All right, angle 1 is 75 degrees. There is no math to do, okay? And I just want you to abbreviate vertical, and I know what you mean by that. Angle 1 is 75 degrees because it's vertical to the given angle measurement. Now, I want you to find, we just found angle 1, I want you to find the measurement of angle 2 now. I want you to find the measurement of angle 2. This is just more practice from what we just did in example 1. All right, everybody right now on your paper, find the measurement of angle 2, turn to your neighbor, and see if they got the answer that you got. All right, did you get the same answer? Did you get a different answer? What did you get? Okay, I want you guys talking. What did you guys get? All right, make sure you're checking with everybody. Don't leave anybody out. All right, ask the person behind you. Ask the person next to you. Can anybody explain to me the measurement of angle 2? Raise your hand. Gavin.
105 because they're neighbors.
They're neighbors. They're next door neighbors, guys. Look here. Do they share a common side? Are they next to each other? Look, angles 1 and 2, or you could say 2 and 75, they're next to each other, meaning, so angle 1 was already 75 degrees. When you add up their measurements, is 105 plus 75 180? Yes. And they lie on that same straight line. So angle 2 is 105 degrees. Okay? Because it is adjacent, ADJ, to angle 1. Adjacent to angle 1. Now we have one more angle measurement on this intersecting point, angle 3. Write down the measurement of angle 3. There's 2 ways, right, Hope? There's 2 ways that you can figure out this angle measurement. Go ahead and write it down on your paper. What is the measurement of angle 3? Okay, do you remember when I told you 75 and 75 were vertical? So 105 and angle 3 would be 105. They're also vertical. Vertical angles are equal in measure. So this one is 105 degrees because it's vertical to angle 2. It's vertical to angle 2. Well, now I have everything filled in on one intersecting location. But now I have to somehow transfer over that information to the other set of intersecting points. And I can do that by using corresponding angles. Corresponding angles. The same angle that's located in the same location on the other intersecting point is the exact same measurement. It's the exact same. So which angle corresponds with 3? Which angle corresponds with angle 3?
7.
Hold on. Look here. Angle 3 is right here in the bottom right corner. So which angle corresponds with it?
7.
Angle 7. Okay, so angle 3 is in the bottom right, and so is angle 7. What was angle 3? 105. So guess what? Angle 7 is 105. 105 because it corresponds with angle 3. What's the corresponding angle for angle 1? 4. So what was my measurement for angle 1? 75. So guess what angle 4 is? 75. Because it corresponds with angle 1. It's in the same exact location. So based on that information, I want you to find angles 5 and 6. Same thing. I want you to write the angle measurement for 5 and 6, write it down, and then compare your answer with a neighbor. Did you get 105 degrees for angle 5? Raise your hand if you got 105. Raise your hand. Did you get 105 degrees? Because angle 5 corresponds with what angle? Angle 2. What about angle 6? 75 degrees because it corresponds with the given angle measure. Okay? All right, so angle relationships, guys. Angle relationships. So now we're going to add 2 more to the mix. Okay? But before we do that, can anybody raise your hand and tell me which angle is vertical to angle 1? Okay? Raise your hand. Which angle is vertical to angle 1? All right, someone raise your hand and tell me. All right, I should see everybody's hands going up. Which one is vertical? Vertical means opposite. Vertical means opposite. All right, what do you think, Sequest? Which angle is vertical to 1?
See?
No, it's got to be, nope.
4.
4 is opposite. How many of you guys were thinking 4? Was anybody thinking 4? So 1 and 4 are vertical, meaning that they will have the same measurement. Someone raise your hand and tell me what is an adjacent angle to angle 1. Somebody raise your hand and tell me. Come on, I should see everybody's hands going up. Jose, what do you think? Which angle is adjacent to angle 1? It's its next door neighbor.
3.
Angle 3. What is another adjacent angle to 1? Tell me. 2. Okay. Now, someone raise your hand and tell me what is the corresponding angle to angle 1, Cade? Angle 5. Is that what you're going to say, Lucy? Because 1 and 5 are both in the top left section of the intersecting points. Are we doing better on that? Okay. So now let's talk about interior and exterior. That all compares to your parallel lines. All right, so does everybody see which lines are parallel right here? Okay, so if they're interior, what do you think it means for something to be interior? It is inside. So if they're interior, it means that they are inside the parallel lines. So what would alternate mean? Alternate means that they are on opposite sides of the transversal that's cutting through the parallel lines. So let's take angle 3. Angle 3. The alternate interior angle would be on the opposite side of the transversal, but still interior. So my alternate interior angle pair is angle 3 and angle 6. So how does this help me? Well, if I know the measure of angle 3, then I also know the measure of angle 6. It's the exact same. So what is my other angle pair? My other alternate interior angle pair. Raise your hand. What is it? It is 4 and 5. On opposite sides of my transversal, angles 4 and 5 are congruent. So now let's talk alternate exterior. Well, it's probably exactly what you're thinking, right? Exterior means outside. Outside my parallel lines. Alternate exterior. So let's start with angle 1. If it's alternate exterior, it's going to be on the opposite side of the transversal on the other intersecting point. So angles 1 and 8 are congruent. Someone raise your hand and tell me, what is my other pair of congruent alternate exterior angles? Anybody raise your hand and tell me? Anybody? Anybody? Come on, guys. What do you guys think? Braden, what do you think? What is my other pair? I had 1 and 8. Alternate exterior. What do you think your other pair would be? 2 and 7. Very good. Okay. So angles 2 and 7 are also congruent. So how in the world does this help me? Well, remember, if I know relationships, then I can solve for something that I don't know. Like here, I have some airport intersections. All right, the photo shows a portion of an airport. You think you have to know angles when you're flying planes? You better believe it. Okay? Describe the relationship between these pairs of angles. So I have angle 3 and angle 6. And notice where your vertical lines are located. Okay, so here's your vertical lines. How are angles 3 and 6 related? What kind of pair is that? Are they corresponding? They can't be vertical, right? Because they're not sharing a vertex. They're not directly opposite. They can't be next door neighbors. They can't be adjacent. Maybe one thing that we just learned in the last slide. Noah, what do you think? What kind of relationship does angle 3 and 6 have? No, that's not an angle pair. Colin? Yep, what was that word before it? Alternate exterior. Do you guys see how they're on opposite sides? Angle 3 is on the bottom. Angle 6 is on the top. And they're on opposite sides of the transversal. So 3 and 6 are alternate exterior. And yes, you can abbreviate. So now I want you to answer what angle pair is 2 and 7. Answer it and then compare your answer with a buddy. 2 and 7. What do you guys think? 2 and 7. All right, angles 2 and 7. All right. What kind of angle relationship do we have here? All right, anybody? Josh, what do you think?
Interior, alternate.
Yes, alternate interior. Did you guys catch that?
Yes.
Alternate interior, because look, they're both on the inside of your parallel lines and they're on opposite sides of the transversal. Who said alternate interior? Anybody else? Anybody else say alternate interior? If you didn't say that, do you understand why? Because we're about to do some classwork. Okay, who said no? Talila? Okay, so Talila, do you see where your parallel lines are? Do you see where your parallel lines are right here? Okay, so my rule says if the angles are inside the parallel lines, do you agree that 2, 4, 5, and 7 are all inside your parallel lines? Okay, so alternate interior means that the angles are on opposite sides of your transversal, that line that's cutting through the parallel lines. So because 2 and 7 are opposite, they're alternate interior. Okay, so now it's going to tell me the measurement of angle 4 is 84 degrees. You must tell me what is the measurement of angle 3, what is the measurement of angle 5, and what is the measurement of angle 6. Okay, this is the last thing we do, and then we're going to get started on homework. When you have your answers, I want you to raise your hand. I'm going to come check, and you can get started on your big ideas. All right, guys, angle 3, how does it relate to angle 4? It's its next door neighbor, right? Doesn't it share a common side? So what do their measures need to add up to? What do they need to add up to? 180. So 180 minus 84 is 96.
I got it right.
Okay? You got it right, but did you guess? Okay, you want to make sure you didn't guess. So I say 96 because it's adjacent to angle 4. What about angle 5? Did anybody get that one, Jada? Yes, it is 84 degrees. The same as angle 4. We were just talking about this, right, Talila? They're alternate interior. So that means angle 5 is also 84 degrees because it's alternate interior to angle 4. What about 6? There's an easy way to find 6. Well, really 2 easy ways. Neighbors to 5. 6 is neighbors to 5, so you can subtract from 180. What about alternate exterior to 3? 3 and 6 are alternate exterior. So that means that 6 is 96 degrees. Alternate exterior. Okay? It's going to take a little bit of practice. All right? Somebody name me one kind of angle relationship that you learned today. One kind.
Alternate.
Alternate exterior. Those angles are equal. Give me another one. There's 5.
The ADT.
Adjacent. What are those? They add up to what?
A180.
They add up to 180. They're neighbors. Kate. Vertical. What do I know about vertical angles? They're the same. They're the same. What's another one?
Congruence.
No. It does start with a C, Thomas. Okay, did we say alternate interior yet? Alternate interior, alternate exterior, vertical, corresponding, same location, two different intersecting points, and then my last one, we said adjacent.
Yes, I said it.
Okay, so that covers them all. All right, guys, that's everything you need to know for today's lesson.